All right. And then we have the volume. The pressure, this is known as Dalton's law. Dalton's law is typically expressed in this form. P total is equal to PA plus PB, however many gases you have in this mixture. We could do the same thing over here. For the total, N total is equal to NA plus NB plus, just sum up all the moles of each component. We get the total. So this one is called what? This one's called Dalton's law. Dalton's law. And then we have something called the mole fraction, right? Or mole percent. And so the mole percent or fraction is going to be given by, not mole, sorry, volume. Volume percent or volume fraction is going to be given by VA over V total times 100% or VA over V total. And then we have this, that the total volume is equal just to the sum of the volumes. We call these partial volumes, we call these partial pressures. And so we look at the partial volumes. The partial pressure. But these two cannot simultaneously be true. Right? Either one or the other must be true. And so up here with Dalton's, we have a restriction. What's the restriction on Dalton's? The restriction on Dalton's is constant volume. The restriction on this one, what do we call this one? Avogadro's. This is going to be constant pressure. And so the pressure of all these gases is the same. And so we have this other equation, that is the pressure total is equal to the pressure of A, which is equal to the pressure of B, which is equal to the pressure of C dot dot dot, right? All the pressures are equal. Up here in Dalton's, all the volumes are equal. And so the volume total is equal to the volume of A, which is equal to the volume of B, which is equal to dot dot dot. And so this is the way we visualize gas mixtures. And so if we take a sample of air, automatically, and we're dealing with gas mixtures all the time. Any kind of chemical reaction, you got to mix the gases. Well, how do you mix the gases? Do you mix it by volume, or do you mix it by pressure, or do you mix it? If you mix it by mole, then no worries, right? But how do you measure out the moles? Well, you measure out the moles either by volume or by pressure. And so we run into the situation where anytime we need to deal with a gas mixture, we got to figure out how we're going to mix it, actually. And so let's take a look at this. So we should be able to rapidly do this. If we have air, we said air is about 80% nitrogen, 20% oxygen. And this is by mass or by mole? By mass or by mole? This is by mole. Well, it turns out that the mole fraction, interestingly not, the mole fraction, Na over N total, or the percent, the mole fraction is 2 out of 10, 8 out of 10, right? The mole fraction is equal to the pressure fraction, which is equal to the volume fraction. In other words, if this is 20% nitrogen by mole, then it's going to be 20% nitrogen by pressure and 20% nitrogen by volume. The problem with this is we know that these two here have restrictions. Right? These can't be simultaneously true. And so this one again was constant volume, this one's constant pressure. And so when we look at a gas, we automatically think of two ways of looking, or three ways. Three ways, because the mole percent is always true, right? Mole percent is always true. But somebody might ask you, you know, if you have 100 moles, then you got 20 moles of oxygen and 80 moles of nitrogen. That's easy. If you have 100 liters, how many liters of oxygen do you have? If I have 100 liters of air, how many liters of oxygen are there? There are 20 liters of oxygen and 80 liters of nitrogen. If I have 100 atmospheres of air, how many atmospheres are there? Well, there's 20 atmospheres of oxygen and 80 atmospheres of nitrogen. But those cannot be simultaneously true. So when we visualize something like this is the way we visualize it. I mean, it could be mole, or it could be a pressure fraction. If it's a pressure fraction, let's do 100 liters here. Let's say I have 100 liters at 1 atmosphere. We'll just do 1.0 atmospheres, keep it simple. Okay, so when I visualize this as Daltons, let's do Daltons. When I do this as Daltons, how many liters of nitrogen do I have? How many liters of nitrogen? If I'm thinking in terms of Daltons, how many liters of nitrogen do I have?